Okay, all of us here. We shall discuss about what is the escape velocity, orbital velocity, and how the satellites will work, geostationary satellite. We shall discuss about all these things now. Just see. So first of all, we shall discuss about what is the meaning of orbital velocity. Okay. So what is the meaning of orbital velocity here? Now just see. So this is the Earth. Okay, and you are considering that a body is thrown from the Earth in such a way that it falls into the orbit. Okay, it falls into the orbit and starts moving with velocity like this. It continuously moves in the orbit of the Earth. So the initial velocity with which the body is thrown, so that it will fall inside the orbit, is called as orbital velocity. The velocity with which the body is thrown from the surface of the Earth, so that it falls into the orbit and it starts rotating. That is called as orbital velocity. So when the body is orbiting here, what are the forces acting on the body? So you should remember that the forces acting on the body is called as, one is centrifugal force, another is said to be gravitational force. Okay, so let us consider the mass of the Earth is m and the distance between the two bodies is taken as small r. So here force due to gravity is counterbalancing centrifugal force, the reason because of which the body is orbiting around the Earth here now. So what is the gravitational force? G capital M small m by r square, which is nothing but V v naught square by r. So r gets cancelled, m gets cancelled. So v naught is equal to, square goes to this side, becomes gm by r. This is called as orbital velocity, the first formula for orbital velocity. Then what is the second formula for orbital velocity? We should discuss about that. So what is the next formula for orbital velocity? You all know G is equal to gm by, what is that? R square, gravitational intensity. Okay. So what do you write from this? See here. So you are throwing a body from this, it is going to fall on the orbit. So here the distance from here to here is small r, where small r is said to be capital R. This is the radius and this is the height from the surface of the body. So try to understand what I am explaining here now. So this is from here to here radius and from here to here height, and the total distance is taken as r. So small r is taken as capital R plus h. Small r is taken as capital R plus h here. Okay, so here I am taking g at certain height, which is gm by r square. So g into r is equal to g capital M by r. Hope you are understanding. So g is equal to gm by r square. Where what is g here actually? G is g at certain height, which is taken as gm by r, means r plus h whole square. You know about this, isn't it? G at certain height, the formula, you know about this, isn't it? But instead of r plus h, I am taking small r, the distance between the centers of the two bodies. So what is going to happen now? So one r I have taken, one gm by r I have taken like this. Okay. So from this, you will understand that this can be substituted here. Then you are getting orbital velocity like this. Okay. So orbital velocity is nothing but, instead of gm by r, we can write this as just gr, root g into small r. So orbital velocity is taken as g into small r is nothing but capital R plus h. Hope you are understanding what I am saying. Yes. Okay. So this is called as orbital velocity. Okay. So here, if h is much less than r, h can be neglected and h can be removed here. Okay. So you can remove this h. Then finally getting orbital velocity as root g into r, where g is taken as 9.8, r is taken as 6400 kilometers. If you want to convert into meters, you should multiply with 1000. So nearly you are getting approximately above 7.2 to above 7 point something 9, 7.8, 7.2 like that, above that, up to 8. Okay, so what is this? This is called as orbital velocity. So nearly you can take this as 7.2 kilometers per second, not meters per second. Means you have to throw in such a speed that in 1 second it has to travel 7.2 kilometers. In 1 second. If you throw with that speed, it will fall into the orbit and starts revolving. Then two forces acts on that, centrifugal force, gravitational force, make them equal. Okay, so what is this distance from the center to this body, which is taken as small r, where small r is taken as the sum of radius of the earth plus height from the surface of the earth is taken as orbital velocity. So therefore this is the small explanation about orbital velocity. Let me discuss about what is the meaning of escape velocity. Okay, so here what is the meaning of escape velocity? Okay, so you just see here, I have taken the earth and I have taken an orbit surrounding the earth, and I have taken one body, okay, which has been thrown from the surface of the earth in such a way that that body goes and escapes from the orbit. Okay, when you throw the body with certain velocity in such a way that this body will escape into the universe. Now it has crossed the orbit. When it has crossed the orbit, it is not under the control of the earth now. It has crossed the gravitational field of the earth. It has crossed the orbit. It is falling somewhere in the universe. Okay, so let us take this point as A and this point as B now, and let us derive what is this? What is said to be escape velocity? Now let us just here, no escape velocity. So here, this is the earth here. This is position A. There is position B here. So total energy at A is going to be equal to total energy at B. Okay. So here, what is the total energy at A? Potential energy at A plus kinetic energy at A. The total energy at B will be potential energy is also zero. Kinetic energy also is zero because it will be suspended in the universe. Suspended. It doesn't have any velocity there. It doesn't have any velocity there. Neither potential energy is there because once it has crossed the earth, potential energy becomes zero. Once it has crossed the earth, its velocity will not be there. It will be suspended in the universe. So both are going to be zero here. And you know the formula for potential energy. The mass of the earth is capital M and the mass of the body is taken as small m. So we write potential energy as minus G capital M small m by R. Okay. What is that R? That is capital R at this position, which is taken as capital R here. Okay. So what is the kinetic energy at this place? Half m VE square, which is total energy is going to be zero. Okay. So what is the kinetic energy with which you have thrown at A? At B, nothing is there. No energy is there. Total energy is zero. So potential energy formula is. So what is the formula for potential energy? You all know the formula for potential energy is G m1 m2 by R. Okay. Minus G m1 m2 by R. So here radius of the earth is taken as capital R. So we write this as like this. So you can take half mve square left side and this you can take it as right side. G capital M small m by capital R. So what do you understand from this? What are things getting cancelled here? Small m is getting cancelled. Escape velocity 2 goes to that side, becomes 2g capital M by R. Okay. So similarly, you can just also write V is equal to root of 2g capital M by R. So finally, how can you simplify this and write the final formula here? How can you simplify this? Let us see. So escape velocity here, to find out that you should know G is equal to Gm by R square. Do you know this one? G on the surface of the earth is small g is equal to capital Gm by R square. From this you can take one Gr separately and one Gm by R separately. One R I have taken in the numerator. So instead of Gm by R, can I write it as Gr? Is it? So I take one Gm by R, one R upwards. So here Gm by R is present. Instead of that, I will write it as 2Gr. Okay. So whereas orbital velocity is just Gr, whereas escape velocity is root 2Gr. So what is the relation between these two? So escape velocity means root 2 into root Gr. Can you write like this? Root 2 into root Gr. Escape velocity is nothing but root 2 times of root Gr is nothing but orbital velocity. So escape velocity is root 2 times of an orbital velocity. Hope you are understanding what I am saying now. So this is a simple method to find out orbital velocity. Okay. So previous year in the year 2026 there was a question asked here. What happens when you take the body to a height h equal to radius of the earth? What happens to the weight of a body? What happens to the weight of a body when you take a body from the surface to certain height h? So what is going to happen here? This is A, this is B. Understand? That is A and this is B here. So what is going to happen at this place and there when you take a body from here to here? That you have to find out. For that I have created one shortcut formula. Weight of the body when you take from here to there is taken as weight. What happens to weight of a body means we can just write as mgh by 1 plus h by r is the shortcut formula. I will derive and show how you are getting this shortcut formula. You can derive also and show you. So when you take a body from here to there, what happens to the weight of a body? When you take a body from the surface of the earth to certain height equal to radius of the earth, let a certain height equal to double times of the radius of the earth, or you can take to a height equal to triple times of the radius of the earth, then what happens to the weight of a body under? So the formula is W is going to be mgh by 1 plus h by r. Here it is equal to h equal to r, no? So we can write this as mgr by 1 plus r by r. So W is equal to mgr by 2 is going to be your answer. Understood? This is the formula.